If you had integrated science, biology, chemistry, so you should know some stuff. The basic idea is that this one's in color, but solutions of water could be neutral or acidic or basic. And the pH scale goes sort of from 0 to 14. You might know that a pH of 7 is neutral. So pure, clean water with nothing in it has a pH of 7. So just plain old water. But whenever you have water, it's usually like a solution. There's stuff that's dissolved in the water. And stuff that's dissolved in the water could either make the water acidic or basic. And there's examples here of different things and their acidity. So like coffee, soda, lemons, stomach acid, acid that's in, well, not this kind of battery, but lead acid batteries are acidic. So acid solutions have a pH that's less than 7. And then you can also have solutions that are basic, like with ammonia, soap, bleaches, a lot of cleaners have a pH that's greater than 7. So like a pH greater than 7. It turns out ocean water has a pH of about 8.2. The ocean is basic. The ocean has a pH, it depends upon what part of the ocean, but the ocean is slightly basic, which is opposite of being acidic. Sometimes streams and lakes inland can be acidic or basic. It depends upon like what's in it. Yep. Yeah. So that's a good and important question. Limestone, we're going to talk a lot about limestone for a lot of different reasons, is made by coral. That's like calcium carbonate. And calcium carbonate can be dissolved by acids. So if the ocean was acidic, acid would break down. So like shells of crustaceans, like shrimp, krill, clams, if the ocean were acidic, those shells couldn't form. Those shells would get broken down by the acid. So it turns out it's necessary for the ocean to be basic so that the seashells can stay strong. Does that make sense? So this limestone, we're going to do a separate thing about limestone, is calcium carbonate. If that reacts with an acid, then it like dissolves. This is not like exactly the chemical equation, but the calcium carbonate will dissolve in acid. In fact, we intentionally do that with some equipment that we use in the fish room called a calcium reactor. I take calcium carbonate, react it with carbon dioxide, which forms an acidic solution, and it breaks the limestone down to help more coral grow. I'll show you how that works, and like we'll deal with that. Okay, so that's a thing to know. That's a very basic thing about water and water solutions. So there's a couple things that I want you to investigate and some things to learn, some resources that are online that are good things to know about. Let me get to the lab thing itself. New share. So toward the bottom of the front page on there, I described some stuff about whether things are acidic or basic and the things that make solutions acids or bases. Let me get to this. All right. So one of the important things to know is that carbon dioxide, CO2, plays a really important role in whether or not solutions are acid or base. The perfect example is that soda, like carbonated beverages, the bubbles in that, that's carbon dioxide. So if you get like a nice cold bottle of Coke and you first crack it open, it's got a lot of carbon dioxide. It's like, like if it's really cold and you crack it open and you chug it real fast, it's really like, it's almost too much. You know what I mean? It's like too cold, too acidic. You kind of like gotta let it chill a little bit. As the carbon dioxide bubbles out of solution, the soda goes flat. It loses the acidity. So the more carbon dioxide you put into water, the more acidic it is. And what happens is when water and has carbon dioxide in it, it makes this H2CO3. That's called carbonic acid. And actually, usually one of the ingredients listed on soda, it'll say carbonic acid. And carbon dioxide, when it's in water, because it's an acid, it lowers the pH. So it makes the pH closer to being 7 or even acidic. So we have carbon dioxide in our atmosphere, and that carbon dioxide in the atmosphere gets dissolved in the ocean. And the more carbon dioxide there is, the more carbonic acid ends up in the ocean, and it ends up in like an equilibrium with the carbonate anions. So a thing that's an important deal to know, and I brought this up a lot in this class, is the role that uh, Hawaii plays in oceanography. It's almost not to say like every day. There's like kind of weird obsession with oceanography or with Hawaii, but Hawaii is out in the middle of the Pacific Ocean. And the big island of Hawaii has two peaks. One of them is Mauna Kea, and the other one is Mauna Loa. And in science, those two mountain peaks, Mauna Kea and Mauna Loa, are incredibly famous. Mauna Kea, the one to the north, is famous because some of the world's greatest astronomical observatories are at the top of that mountain. The Keck Observatory, which is a pair of telescopes, NASA's Infrared Telescope, the Gemini Observatory, the Subaru Telescope, James Clerk Maxwell. Basically, the top of Mauna Kea has the collection of the world's finest observation telescopes. So the reason why those telescopes are on top of Mauna Kea is that it's a very tall mountain, so you look through less of the atmosphere. Because electricity is really expensive in Hawaii, people don't have outside lighting and don't have them on at night. You know, like if you go to like Walmart or Target at night, the parking lot's all lit up. They don't have outside street lights in parking lots in Hawaii. It's almost like the store is closed, dead. Electricity costs about 10 times more money in Hawaii than it does in Pennsylvania. So if your power bill is $100 in Pennsylvania, that same power bill is about $1,000 a month in Hawaii. So people do not like to use a lot of lighting because it's so much money. The other reason why they don't use outside lighting is they intentionally don't light things up outside, and it keeps the sky really dark. So at nighttime, you have this like a dark sky, which is good for astronomical observation. Less light pollution. That's exactly what they call in astronomy is light pollution. It's not really pollution, but you know, it's like if you're in the city and you look up at the night sky, you might see a couple stars, but you go somewhere really rural, you know, and you're away from the city, it's unbelievable how many stars you see. And it's just simply because you don't have like street lights, you know, the light bounces off of moisture in the atmosphere and clouds and stuff, and it makes the sky look kind of milky. Even like, you know, if you're coming down the belt, like if you're coming from like Linden or Jersey Shore or even from Montoursville, like at night, as you drive toward the city, you can see like a glow over the city, and that's from like the outside lights, right? Yeah. No, yeah, there's lights in the store, but you know, like the outside light's not lit. There's no lights in the parking lot. You know what I'm saying? Yeah. So what I mean is like, you know, you kind of know that something's open because like if you were to drive by a McDonald's that closes at like 10 at night, when they close, then their outside light is off, you know, and the arches are not lit. You know what I'm talking about? It kind of looks like it's closed. Yeah, they just don't tend to light them in Hawaii. They just don't light, you know, all electricity is expensive. And because you're trying to reduce light pollution for these telescopes, you just don't have outside lights. So that's an interesting thing to know. But Mauna Kea is famous for the astronomical observatories. The other mountain, Mauna Loa, I just lost it here, has other laboratories. And Mauna Loa is at about the same elevation. And oh, this is being slow. Here we go. Got to find the end of the road. Oh, come on. It's such a small building. Mauna Loa Observatory. Here we go. So on the top of Mauna Loa, there are other laboratories. And these laboratories are world famous. It even says famed atmosphere research station. So what you got is the tippity top of a mountain out in the middle of the Pacific Ocean. And at that location, you're kind of about as far away from civilization as you can get. And this is the place where we monitor and measure the state of the Earth's atmosphere for like oxygen concentration, carbon dioxide concentration. Like, what is the atmosphere like? See, if you were to like monitor the atmosphere of the planet near a city, from summer to winter, daytime, nighttime, as we're like, burning fuel and driving around, you get very rapid changes in concentrations. So the top of Mauna Loa is famous for being a place where we measure the amount of carbon dioxide that's in our atmosphere. And it turns out that when carbon dioxide is in the atmosphere, it also ends up in the ocean. So if you look on the second page, there's a place where you can visit NOAA's website to learn about like what CO2 concentrations are like. I put the link on there at the top, near the top of the page, bit.ly/Mauna Loa 20 or Mauna Loa CO2. And it turns out that is case sensitive. So when you go to that site, you got to make sure that like the Mauna Loa is lowercase and then the CO is uppercase, CO2. And this will show you real time information about gases in the atmosphere, and particularly carbon dioxide. So this is a thing that you might know, or you kind of should know, is that as humans, we create a lot of carbon dioxide as a result of burning fuel, burn gas, burn diesel fuel, just burn fuel, burn coal in power plants. And this is a trend line from 1960 until like literally today, right now, showing the concentration of carbon dioxide in the atmosphere. And the measurements were first started in the late 1950s on Mauna Loa, and the measurement technique has been the same. And the atmospheric carbon dioxide concentration has increased from about 315 parts per million to over 415 parts per million. And that's in 60 years. So the amount of carbon dioxide in the atmosphere of the planet has, gone up about 50% in just 60 years. It's been a rapid and remarkable change. The reason why this looks like zigzaggy, like zigzag up and down, and this is from 2016 until now, is because it represents summer and winter, summer and winter. There's more land on the northern hemisphere and less land in the southern hemisphere. So in the summer, like we're coming into the summer now, and as our plants are growing and putting leaves up, they're consuming carbon dioxide from the atmosphere and putting oxygen in the atmosphere. So that causes the drop. But then when it gets to be like the winter, since the northern hemisphere has more plants than the southern hemisphere, as the trees die, or the leaves die and the plants go into like suspension, then the carbon dioxide concentration increases. So, and there's a little bit of a couple month lag. So it turns out right now, that's the level. And in about a month or so, we will have, once again, the most carbon dioxide the atmosphere has ever had. And every year that repeats itself. And this black line is like the trend line. So here's the deal. As you get more carbon dioxide in the atmosphere, you end up with more carbon dioxide in the ocean because the carbon dioxide dissolves in the ocean. And that changes the pH of the ocean. And that has good news and it has bad news. So the bad news is it makes the ocean more acidic. But the good news is all that salt in the ocean helps to prevent rapid changes in pH. So I want you to visit the site. You can look around and see what the levels are currently. At the top of the page, it has like what the current carbon dioxide level is. And you can see like about how carbon dioxide changes over time. So that's a big and important story. Yeah.
Is it happening too fast for like the
Happening too fast for like the animals in the ocean? Well,
yeah, like the ball to the higher, the lower pH?
yeah, so what we're going to look at is it turns out that like like for shrimp and krill that have exoskeletons, that exoskeleton on shrimp is called a carpus. And the thickness and density of the carpus is much less than it was in the 1960s. So literally, if you took a shrimp out of the ocean in 1960, it would be like hard to squeeze and crunch, and now they're softer. That exoskeleton provides protection for the shrimp. You know what I'm saying? So it puts pressure on animals. Bone densities for fish are less than it used to be. Uh, Animals take a very long time to evolve and adjust. 60 years is way too low. So yeah, it's no time. It is irrefutable the influence that humans have on our atmosphere. The air you're breathing now has like twice as much carbon dioxide as the air that like my parents breathed when they were in high school. You know, it's that's a fact. Now the good news is more carbon dioxide. People say, well, that's plant food. So it turns out that as plants need carbon dioxide to do photosynthesis, there's more carbon dioxide available to them. That's true. So that's kind of a good thing, but that's not like natural. You know what I'm saying? Uh, this is just absolute direct. The reason why the reason why Mauna Loa was chosen in the 50s is because we recognize that we have not only cranking out huge amounts of carbon dioxide, but it's having an effect on the planet. And we're like, we need a good place to get good steady measurements from that's as far away from and not influenced by human activity as much as possible to really be a sample of the atmosphere. This is a mountain 13,000 feet in the air. So it's kind of like up in the middle of the atmosphere, kind of winds are blowing by. You're getting good measurements. You know what I'm saying? It's a good place to pick. So yeah,
Wasn't there like a much more immense amount of CO2 in the atmosphere during the dinosaur days?
yeah, absolutely. So like back in the backety back days, the atmosphere was very rich in carbon dioxide, and it turns out that cyanobacteria, which is present in the ocean, is responsible for making a lot of the atmosphere's oxygen. So in terms of like the time that humans have been on Earth and like modern life like we know it, we are at absolute record carbon dioxide levels. If you go back like, hundreds of millions of billions of years, there are periods of time in the years past where carbon dioxide was like higher. The oceans were acidic at that point, and it's harder for animals to even exist. But yeah, and like
There was more enemies back then than there is now.
yeah, well, we've gone through booms and busts. You know what I'm saying? So
When you get to the next
yeah, but the deal is that this you can even see that this concentration is not only increasing, but the rate is increasing. Yeah. So it's a big question as humans. Can we afford to continue to put CO2 in the atmosphere? And that has a lot of implications. It has implications for like the temperature of the planet, the weather conditions, but for the ocean, it plays a really critical role. A lot of human population relies upon the ocean for like food source and protein and things. If you get to a point where the CO2 is too high and the ocean become too acidic, and those basic creatures that like krill and shrimp and plankton and stuff play in the ocean ecosystem, if they become, they can't survive in the water that's too acidic, it changes the way the food web works. And like there have been times in the past where just removing one staple from a diet can cause an entire civilization to collapse. Like famously, the Irish potato famine. It's like there's just potatoes. How come all these people die? It's just potatoes. Well, if potatoes represent like 20% of all the protein or all the food you get, if you eliminate 20% of all the calories from everybody's diet and everybody's barely staying alive, you start murdering millions of people. So what if all the food stock from the ocean goes away? What if there's no more fish in the ocean? How many people, absolutely rely and depend upon that? I mean, that I'm not saying that's going to happen, but yeah, protecting that resource is really important. Okay, so the deal is that carbon dioxide uh, levels can fluctuate in the ocean, and what we want to measure is how the change happens in saltwater and freshwater. Okay, so on the second, well, you can look on the site and look right down the month and what the concentration is, and there's also an animation. Bit.ly/pump handle shows like the change in carbon dioxide concentration. Okay, what we're going to do on Monday, if you look on the third page, there's a big chart there what you're going to do is just take some different solutions and add acid or base. So if you look on the page that says like buffering capacity of seawater as compared to distilled water, what buffering is the ability for water or a solution to resist changes in pH. In other words, resist the pH going up and down. And what we're going to do is compare fresh water, pure water, with salt water. So when you look on the lab paper, here it says pH of RODI water. We make water here at school where we take tap water and use a reverse osmosis deionization system to remove all the impurities from the water to get us down to pure just H2O. So what you're going to do is take a sample of pure water and then add acetic acid, which is vinegar, dropwise, and measure the pH. So how it goes, I've got these pH probes. I'll tell you a couple things about pH probes. Never used before. We have these meters. The meters, the pH probe plugs into the meter like this. I'll have them all set up. On the screen, it'll display the pH. The pH probes themselves are stored in a solution in this container. So whenever I unscrew it, this bottle comes off. The end of the probe has to stay wet. The end of the probe in there is a glass bulb that has a permeable membrane. Whenever you stick the probe into a solution, it'll tell you what the pH is. So if you put that into pure water, it should say a pH of 7. Whenever you add acid and stir it up, the acidity will rise and the pH will fall to a level that's below 7. And you're just going to add acetic acid dropwise to a solution. So what I mean by that is you take some pure water, you add 1 drop of acetic acid, measure what the pH is. Then you add a second drop, measure the pH. Third drop, measure the pH. So as you add water dropwise, you can see how the pH changes and go up to like 15 drops. Then you're going to repeat the experiment with salt water. Start with a sample of salt water that's from our aquarium system. And when you start adding acetic acid, 1 drop at a time, you'll notice the pH will also change. But what's important is to notice for which of the two kind of solutions, pure water or salt water, does the pH change more. And then NaOH is sodium hydroxide. Sodium hydroxide is commonly used as a drain cleaner. Sodium hydroxide, when you add it to water, will make the pH go up. This is a base. It becomes more alkaline. And you'll notice if there's a greater or smaller change to the ocean water. In a way, where you're comparing is how does the pH change when acid or base is added to fresh water as compared to salt water? And that plays an important role in ecology. One of the stories that we'll talk about with biological oceanography is for like fish that live in the Susquehanna River. In the wintertime, that water is freezing cold with very high oxygen concentration. And then in the summertime, the water gets real hot. And you could have like a real hot, the water could be real warm and it'd be stagnant. And then you might get like a heavy rainstorm and it floods and it gets really like turbulent and the temperature drops very quickly. So fish that live in freshwater, they have to be able to put up with big changes in temperature and pH and turbidity. But in the ocean, things are very steady, very constant all the time. It takes a lot to cause changes in that. Anyway, you calculate the change in pH from the beginning to the end, and then on a graph so you can see it graphically, how does the pH change as you add drops of water for both adding acetic acid and adding sodium hydroxide? Which of them has a greater resistance to change in pH? Okay, then if you look toward the end, and this is what you can work on today too, toward the end, there's last 2 pages, it says ocean acidification investigation. This is like these questions about how does the role of carbon dioxide in our atmosphere affect the ocean itself? And I put a link in the folder. Let me show you where it is. So if you're remote, because you can't collect data, or if you're absent on Monday, and we might take some time on Tuesday too, there's a file here in the folder for chapter 5 that says pH lab remote data. And this provides a data set that's kind of representative of what you would get if you like measured it in class. So if you're remote or if you're absent, you can use the data that's in this table. I don't know, Schoology is like being slow today. I wonder if I'm on the right Wi-Fi. Yeah, mobile devices, that's okay. So there's like a set of data here that is usable. But the other thing that's in the folder, this thing says ocean acidification. One of the good things about us having Schoology now is you can access these things and see them in color. Up until this year, I used to photocopy it and it was in black and white and kind of looked crappy. So the ocean acidification article goes with the last 2 pages of the lab, and you can read this and kind of respond to the things that you see. This is an article and it's as a PDF, so you could download it or view it in line or whatever, about the role that carbon dioxide in our atmosphere plays in understanding uh, ocean resources. And this was developed by UNESCO, which is Intergovernmental Oceanographic Commission, and some other research organizations to talk about, as carbon dioxide rises in the atmosphere, what role does that play in the ocean in terms of uh, ocean resources? So this is in color and it's nice. This shows relative concentrations of carbon dioxide in 2000, and then predicted levels of carbon dioxide in 2100. And there's a scale that's on there. And some things about the role that humans play in both the amount of carbon dioxide that's in the atmosphere, and you can see that that correlates to the amount of carbon dioxide that's in seawater. So as the concentration of carbon dioxide in the atmosphere grows, that's the red line, there's bigger variances with the ocean, but the trend in the ocean is also an increase in concentration of carbon dioxide. At the same time, that additional carbon dioxide in the ocean causes the pH to drop. So the ocean pH also steadily declines. In other words, the ocean is getting more acidic as the amount of carbon dioxide grows in the ocean. That's as a result of increasing carbon dioxide in the atmosphere. That's just directly measured, and we've been very carefully and directly measuring ocean pH and CO2 concentration since the late 1980s. And it's not a surprise what's happening, and it's, totally a big deal. And so like what part of that stuff is natural, what part of it is human based, and what part of it, or how does it affect, us as people and, all around the world. So I know that it's also a politically charged and international topic, but the science doesn't care if you believe it or not. You know, the ocean doesn't care if you believe the pH is changing. Like, science don't care what you believe. If it's happening, it's happening, and you got to make decisions. Yep. Yeah, you can be like, ocean's fake news, right? Like the moon doesn't exist, the ocean doesn't exist. Never seen it with my own eyes. It might not be there. Yeah, you can be sure the ocean is there, and you can be sure that the changes are taking place. Now, there are things that drive carbon dioxide in the atmosphere. It turns out when volcanoes explode, that puts carbon dioxide and sulfur dioxide in the atmosphere. But it isn't like the last 60 years have been as a result of like all these volcanoes exploding. They do make a contribution, but the contribution is mostly like, burning gas, pump the gas out of the ground and burn it up. So I don't know. That's a thing that is an important thing for you to learn and to know from this course. And then as you go through your life, all of the decisions that you make about the things that you do, um, not to say that you're directly responsible for it, but every time you start your car, you're putting a little more CO2 in the air, and a lot of that goes into the ocean. So just walk around instead. Not walk around instead, but yeah, that you might know, and there's no surprise that the world's automakers are transitioning very quickly from gasoline and diesel powered vehicles to electric vehicles. Most auto manufacturers have committed that They're like, yeah, we're in our last generation of gasoline powered vehicles. Uh, Volkswagen has stopped manufacturing or has stopped designing their last gasoline powered vehicle. They're done. Ford has committed that by 2035 there won't be any more gasoline or diesel powered vehicles. General Motors 2030. So I mean we're within like 10 or 15 years from now, like there won't be gasoline and diesel powered vehicles available for sale. Yeah, affordability has changed a lot, right? Because Tesla has been kind of leading the way, and their early vehicles are like 100,000, 60,000 bucks. The Tesla Model 3 is like 30,000, 35,000, which is kind of on the expensive side for a basic vehicle, except you never buy gas for it. So like, see, it depends upon the model and it depends upon where and when you charge. Uh, for the higher end models, you get free lifetime charging. For the lower end models, you don't. But there are places like Sheets offers free charging, you know? Yeah, you don't. You just back up, plug it in. That's it. And Sheets and other gas stations, they have an incentive to do that because then you're going to go in and you're going to buy stuff. And to be honest, you're gonna be more likely to go in and buy stuff because, like, if you just stop to get gas, you stop, you put the gas in, you're done. But if it takes 30 minutes to charge your car up, you're way more likely to go in. You know what I'm saying? You're way more likely to go in. Yep. So the thing is, like, I don't know if you know how the economics of gas stations work. Gas stations don't make money on gas. They don't make money on gas. They make the money inside the store. Because you know what we don't have in Williamsport anywhere are gas stations that only sell gas. Those disappeared years ago. They don't exist because you don't make money on the gasoline. You make the money on the convenience products, the MTO, you make the money in the store. The gas pumps are just a way to get people to be at your convenience store. And that's why places like Sheets and Wawa have become very popular and profitable because not only can you get your gas and get your convenience items, but you can actually get meals and hot food, right? That's the plan. That's how you make money in that game. Even like 15 years ago, all over the town, there were gas stations that just sold gas, and you could make some money selling just the gas. But now the profit margins are so slim. Actually, people argue like before we had Sheets, gas was like kind of more expensive. And what happens is in cities where places like Sheets and Wawa would show up, they'd say, "Oh, Sheets showed up. They put all the gas stations out of business." And it sort of is like that because if a gas station, if their model was, we want to make 5 cents profit on every gallon of gasoline, they've got to have their prices set so they make the 5 cents on every gallon of gasoline. But then when Sheets like comes to town, they're like, we don't need to make that 5 cents. We can sell the gas for 5 cents less. So now we're the cheapest gas in town. We don't rely upon the 5 cents a gallon. We rely upon what we sell inside the store. And what happens is people stop going to the gas stations that sell all the gas because not only is it more expensive, but they can't get MTO. They start going to Sheets, and Sheets, provides the gas and makes the money inside. Like, yeah, Sheets, started in Altoona, and they've built that business model, and they've been able to expand a pretty wide area, and especially in eastern Pennsylvania, where Wawa is more common, like they've been able to grow and expand that same kind of thing too. You know, yeah. So Wise and also famously Sam's Club, like Sam's Club also generally sells gas at like a discount. So people like are like, "Ooh, I can get my gas cheaper at Sam's Club." But you know what? You're in the Sam's Club parking lot. Let's go in and see what they got, right? So the incentive for Sam's Club to put gas pumps in their parking lot is not to like make money on gas, is to get your car in the parking lot. You know what I'm saying? Like, not to say that Sam's Club is like a luxury purchase, but if you live in Williamsport, you have to like make the trip to Sam's Club, right? And what gets you to Sam's Club? Maybe you would just want to go there, but also maybe you're like, I can get my gas cheaper there. Now you're out in that parking lot, you're getting the gas cheaper and you're going in the store. It's not a conspiracy. Yeah, yeah, yeah. Like if I happen to be out that way and I'm almost low on gas, I find myself going in the store too. You know, like yeah,
They got the good stuff there too.
yeah. And uh that's basic supply and demand, getting the feet in the store economics. It's why stores offer sales on it. You're like, yo, we got a sale on this thing. We'll get you in the store and we'll get you buying more stuff. In some businesses, I don't know if you know about products they're called loss leaders, but there are economic models where you offer something even at a loss to get people to buy the product. Famously, inkjet printers are famous for being loss leaders. When you buy a computer, they give you a free inkjet printer. Inkjet printers are like oftentimes sold for less than they cost to make. But the manufacturers don't make money on the printer. They make money on all the ink you're going to buy over the time. Yeah. In the world of aquariums, Petco and PetSmart offer these sale called dollar a gallon sale. You get a 20-gallon tank for $20. It costs a heck of a lot more than $20 to manufacture it and ship it here. But that's a loss leader because if you buy a 20-gallon aquarium, you need a filter, you need lights, you need pump, you need fish, you need to buy food forever. So you're like, we're going to offer people this aquarium. Yep. And it's the same with car dealerships work on that principle. Car dealerships don't make much money on the car. They make money on the service after the sale. You keep going back to get the vehicle serviced. Yeah, even auto dealers will straight up be like, "We're going to sell it at cost." And you're like, "Why would they do that?" It's like, yeah, yep, anywhere else. It's the same with warranty service because if you take it down on warranty, the manufacturer is paying the dealership. So like, you know, that's the way that it works. You get the people in the door and you give them the item and yeah. So the thing is like, if you go onto a new car dealership and you buy a car for $30,000, they might make 1,000 or 2,000. They might make a couple bucks. It doesn't matter. But over the life of that vehicle, they're going to make lots of money on oil changes and all that other stuff. Yeah, yeah, yep. And one thing, they don't want that. Yeah. Sometimes vehicle buyers try to use different tactics and haggling. So let's say you want to buy like a Ford pickup truck and there's a Ford dealership like right down here and you're like, hey, I want to buy this. You could say, well, but there's a dealership out in Sayre or Wilkes-Barre and they're going to give me $1,000 less. And that dealer's like, okay, fine, we don't care. We don't care where you get the vehicle from because you're going to get it serviced here anyway. You know what I'm saying? Like you can't, you're never going to use, but I can get it cheaper at a place that's further away as a bargaining chip because you're still going to get it serviced there. They're actually in some cases happy that you bought the thing somewhere else where they're not even making money, the same as they're not making money, so long as you get it serviced in that location. Yeah. So right. So that's not they make money on the service. So that's not really you can't use that as a bargaining tool. It's smart to shop around, if you can shop around, but you're not gonna like find a dealer who's like really gonna give you a break in price because they don't have a lot of room to haggle. What's that? It depends. I'll, uh, yeah, the last 5 vehicles I've bought have been new, and it's only because the resale value because the interest rates are low on new cars and the resale value is high. We've bought Hondas for like a while now, and like actually we were looking in 2004, we were looking to get a used CRV, kind of like a 2001, 2002, and the interest rate on used vehicles is like 6%, but on new vehicles you can get 0% interest. And because the resale value on recently or on slightly used vehicles is so high, your monthly payment can actually be the same or even higher on a low mile used vehicle than it is on a brand new vehicle. You know what I'm saying?
You know, I think it's as soon as you drive it off the lot,
Yep, you're upside down.
uh,
Yeah, you're upside down on it, but
it's like that's why like if I was gonna buy like when I'm older I want to buy like a performance sports car. So I'm gonna go and I'm gonna try to find the newest vehicle I can that's already used because that's gonna be one that's gonna keep its value for the longest time.
yeah,
It's already a depreciation market. It's not. It's like the first of this. So you want to buy it here. So you only use.
yeah. But we've got two cars now that only have 35,000 miles on them, and they're both paid off. We still got 50,000 miles worth of warranty and another 200,000 miles of use, and we don't owe anything on them. You know what I'm saying? So like, but we also don't drive that much, so that worked out okay. I mean, I know I have friends who like will just buy a used car and then drive it until it breaks and then just get another one. You know, just keep like if it's 3,000 bucks and it lasts you 2 years, that was 1,500 bucks a year for the use, right? Or you can be like, spend $30,000 and get 20 years of use, and it's the same price per year. But it's so much more if you buy a brand new vehicle, you never worry about anything for a long time because like unless it's trash, but it's going to have a warranty, right? So you're going to be taken care of for a long time.
It's like this.
Yeah, but you buy a new car, you're not going to have a problem with the exhaust for like a long time. It's yeah, it's a, my parents used to get their car inspected. They used to have crap cars, and they used to get it inspected at this real dicey place. It was real shady. The dude was like, how it worked was like you just pulled up in front of the place and like honk your horn and turn your blinkers on, and you go in, and he's like, "Well, you made it here, and it sounds like your lights and horn work," and he like give you the stickers, and you'd put them on. It was really shady,
That's always good. So
but
I failed my first inspection with this car because my tires stick out.
yeah,
It's like it's an inch. They stick out an inch and a half from the side. They're not. They have to sit under the fender wells.
yeah,
And so when I go now, I just throw on my